Hey YouTube world, I think it's time we had a talk. My name is Brian Buckosh, core design engineer with Brunswick Bowling, and this isn't my normal intro and this isn't my normal video. This is going to be a very free-flowing, kind of off the top of my head conversation about some of the industry drama that's going on in the world of core designs. Now, of course, you might know that DV8 has a patent pending system of no-thumb technology that's being utilized in 3 of their cores and is in the process of going through review for being patented or not, if we do or don't get that system awarded. Radical has been working with moment arms and the use of torque forces in their core designs for a number of years, dating back to 2013 with the start of Radical, and even previously, Mo and Steve were designing cores with this principle in mind in the Mo Rich days. So I'm going to dive into a little bit of history about the moment arms on the Radical cores, how this system is evolved into a two-handed no-thumb system for the DV8 line with my design principles, and how the new ball on the market of a certain Michael Bay film name is borrowing some of these design principles in their designs. Now, I'm not here to bash a particular brand or a particular marketing scheme from the opposing companies, but what I am here to do is explain how our system works, how the Radical system works, how those two are different from one another in DV8 and Radical, and what design principles are similar and different in the competitor system, and how I feel about them in particular. Again, I didn't write this video out. This is just a free form video that is kind of getting my take on the topic out in the open, expressing my opinion to you, seeing if you, the bowlers, have a similar or different take. But in this, I do think I have to talk a little bit on the physics side of things, because this is a very physics-heavy conversation. So what I've done is I've put the timestamps in the description below. If your eyes glaze over when you start hearing physics terms and you don't want to hear me talk about that up front, which is what I'm going to do now, then go ahead and skip to the next section where we talk more about the individual systems for DV8, for Radical, and for the other core by the opposing brand. And that might be the more fun section of the video anyway, right? But first, let's talk a little bit about torque, since that's what the competitor's presentation is all about. Now, of course, torque is just a force, and it is a force in a rotational direction. So if you think about it, if you push a box in a linear direction, that's just general force, right? Well, if you rotate an object about an axis, that is a rotational force. That is considered torque. So the very obvious, easy, rudimentary example is tightening a bolt or loosening one. Let's use that example. So you've got a rusted bolt on a car. You don't reach for the smallest little wrench if the bolt is rusted, right? You usually use a big hefty wrench with a long arm. That arm is a moment arm, and the further that you apply the force out on that arm, the easier it is to torque or to apply force to the point of rotation down here, right? So if you've got something that's really stuck and rusted, you use a big long breaker bar and you apply that torque far out on the end of the handle to get it to rotate, right? So effectively, there is utility in core design about applying mass in different locations to get different torque forces about the center of rotation, which is the geometric center of the bowling ball. Of course, in terms of rotation, you're going to talk about angular momentum as the force, and the angular momentum vector will chase the torque force in bowling. That's just a little aside about how this works. And how it's applied in bowling is cores are not designed so that the center of mass is the geometric center of the bowling ball. There's a very, very small offset to the pin side or up, and toward the CG side, or to the right if we're talking about it in spatial coordinates, right? So when it goes up and right just a little bit, then what you've got are pinouts. Your CG distance is in the range from 2 to 4 inches from the pin, and your top weight is going to be in the range from 1.5 to whatever, 4.5 inches on the untrilled bowling ball. That is just a measurement of how offset the core is from the geometric center of the bowling ball. Now, of course, this all operates as a whole system. You're not throwing just the core down the lane. So you can't just consider the core shape itself. You also have to consider the outer core compound and, of course, the spherical shell that surrounds all of it when you're talking about this as a system that is rotating. So because that geometric center of the bowling ball and the center of mass of the assembly of the inner core, outer core cover stock is offset, it's creating a torque force as that center of mass rotates about the origin of the bowling ball. And so that is causing precession in the axis of migration. So that is what effectively Storm is talking about when they're talking about torque-induced precession. It's kind of just the offset of the overall design assembly that includes the inner core, outer core, and cover stock. Now what's interesting is that torque-induced precession is just one small part of the overall effect of the core design on ball motion. And it's most greatly affected by the offset, the pin out the top weight, effectively static weights. Now, of course, static weights are only static when they're sitting on the table. When you set them into motion, they are creating this torque force. So in effect, they do have some effect on the overall ball motion. Now, the caveat that I'm going to give you here is that we're designing all of these cores within the same box of pre-drilled targets. And after drilling, all of the balls, and including the layouts, are limited by the USBC's regulation on top weight and side weight. That's 3 ounces in any direction from the center of grip of the drilled ball for the statics to balance. In other words, you can have 3 ounces more side weight on the right side than the left side, or vice versa, but no more than that, or else it is deemed illegal by the USBC. So when we design our undrilled balls, we take standard layouts into consideration, and we make sure that our designed pinouts and top weights of the undrilled ball will result in relatively good drilled specs for the average layout for the average bowler. Now, there are some trick layouts and some weird things that pro shop operators do that push the limits of those statics, and that's okay, because ultimately the pro shop is responsible for the final drilled ball statics, not the manufacturer. But all of this is to say that all cores that are pro performance, that have an inner core that has differential RG values, all of those things, they're designed to fit that window of specification. You're not going to get too far out of that realm, meaning that relatively speaking, with or without moment arms, with or without precession wings, with or without any of the other design features and nuances of the inner core's core design, they're all going to have a relatively similar torque-induced precession. And it's actually the torque-free precession that has everything to do with the RGs and the differential, meaning the difference between the RG values of the axis, say the pin axis, the mass bias axis, and your intermediate axis sticking out in the opposite direction. The difference in RGs, or the difference in weight distribution among all of those axes in and among them, is going to be what causes the asymmetry, what causes the torque-free precession, and what causes the axis migration across the face of the drilled ball after you drill into it. So that is by far and away the larger and more meaningful component of the equation of torque that is involved in the whole system of bowling balls. And that is the primary focus of both the DV8 system and the radical system. What's really interesting about core designs is that they don't follow the simple physics that you find in college textbooks that talk about torque. Because torque is usually talked about with a primary axis of rotation, such as a bicycle wheel, that is stable and on its preferred spin axis. However, bowling balls, when they're traveling down the lane, their axis is migrating both because of torque-induced precession, but also because they're being thrown on a random axis that isn't relative to the primary axis of the bowling ball. That is your PAP. Because of both of these things, your axis migrates, and because your axis is migrating, every time the ball makes a revolution, the shape of the core relative to the migrating axis is different, because you're spinning that object on a different axis every single time. I know a lot of these principles are a little in the weeds and a little complicated, but they really are the underlying design principles of why the shapes of the core end up like they do. Now, Radical's been doing this design type work for a long time, so let me talk about their system a little bit first. Mo Pennell and Steve Freshour have been working on this type of stuff since the Mo Rich days. The first core to my eye that really had a moment arm that stuck out in a particular direction for purpose-built torque was with the Ripper series that was also in the Destroyer and the Hooker balls, funny name, in the Mo Rich days. This is 2011 we're talking about here. Those designs advanced in Mo Rich, and then when Mo and Steve both came over to Radical Bowling in 2013, these design elements came in with the Radical Reax version 2. As you can see, I popped this core up here, and they basically shaved the 45-degree sides of the inner core to stick the nose of the core out further. That is going to be a moment arm that causes torque about the axis of rotation. Now, fast forward, you see this a lot. The Guru is the most obvious example, is the most famous example, and one of the best-selling balls that Radical's ever had. Huge nose out front that you can impact with the thumb to create a real change in RGs, differentials, and intermediate differentials, but also a moment arm that creates a torque force as the axis migrates across the face of the ball. From the Mo Rich cores, from the V2 core, from the Guru core, and from all of the cores in the modern era that are pro-asymmetrical balls in the Radical lineup, there's one common design trend. They have moment arms on the intermediate axes that create asymmetry, and a big moment arm on the front x-axis, that we'll call it, if we're talking about x being toward the mass bias and y being up. I know different ball companies and different CAD programs define them differently. We've always designed with y up and x at the mass bias. For Radical, you can kind of define this system as a moment arm that lies in the xy plane, that is the line from the pin to the mass bias. It's the pin to spin line, if you guys are familiar with my Radical rundown stuff. On that pin to spin line, that is where that moment arm is centered, usually in the area of the mass bias, but almost always above the midplane of the ball, or in other words, above the equator of the ball, meaning that it's a little higher, a little more toward the pin than it is toward the opposite negative side of the ball. That does a couple things. That is going to allow torque to take effect in the proper direction as the ball loses axis tilt and rotation, and it also places the moment arm in a great place to be intersected by the thumb hole should you choose to drill it that way. Now, of course, this purpose-built moment arm is being used as a tool to manipulate the after drilling numbers. Basically, if you drill your thumb hole into that moment arm, you're skinnying up that core overall, which reduces the torque force of that arm in particular. But again, these cores are being designed with multiple moment arms. You've got them on the intermediate directions, and you've got a small arm on the back of each core that counterbalances to make sure that the RG min stays where it belongs. So when you drill into one of these moment arms, you're blowing up the total differential by maximizing the max RG axis. You're blowing up the intermediate differential by maximizing the max RG axis relative to the intermediate axis. And because of that, you get post-drill numbers that are much higher. In other words, the range of ball motion that you can get by drilling either into or missing this moment arm is much higher. So that is the underlying principle of the Radical system. The DV8 system relies on similar principles with similar moment arms, but up in the range between 3.5 to 5.5 inches for your dot to center of grip distance. Remember, DV8 fundamentally focuses on no-thumb bowling in their core designs. So their core designs are purpose-built with a patent-pending system, and the system is outlined very clearly by 3 distinct zones that the core is built. It's got a core top that is defined by a knob, effectively. That is zone number 1. It's got a void inside the core that is filled by the outer core compound. This is zone number 2. It is purposely very far away from the shell in this zone. And in zone number 3, the range from 3.5 to 5.5 inches from the dot to the center of grip is the core side, akin to the moment arm or the nose of the Radical core or the precession wing in our competitor's ball. What this does is it gets the inner core very, very close to the shell of the ball, which means mass is very far from the focal point. That allows for greater torque force, and it also allows you to manipulate the post-drilled numbers very readily by immediately hitting that inner core material with the drill bit when you drill into it. So just like the moment arm on the radical core, when you drill your fingers into the core side in zone number 3 on these DV8 cores, you're going to change the numbers of the differential and the intermediate differential quickly and immediately. We've got cores that are built with, let's take Troublemaker as a perfect example. Very moderate symmetrical ball undrilled. 250 on the RG and 045 on the total differential. You can drill that pin to center of grip distance in the range of 5.5 inches, and you will get a post-drilled value of 058 total differential and 018 in intermediate differential. So a high flare potential, high asymmetry ball after drilling with just 2 fingers in it because of the location of the mass. The accusation from some people is that the competing company has copied the homework, so to say, of the Radical and the DV8 core designs. And it's a little hard to argue against that, and I say that only because the distance, 3.5 inches to 5.5 inches, the exact distance that we use in our patent-pending DV8 system, is also the exact distance that the competitor's precession wing is inside the ball. So if you drill a no-thumb layout, 3.5 inches to 5.5 inches from the pin to the center of grip in their ball, you will hit their precession wing in the exact same way that you hit the core side of the DV8 system. And this is true of the Heckler series ball, the Troublemaker series ball, and the Dark Side series ball. All of those cores are designed with the exact same system in mind, where you can drill the certain distances to get the varied effects of the after drilling numbers. That 3.5 to 5 inch distance is constant in our system for these core designs. And what do you know? To the number, the exact inch distance, the precession wing presides for the competitor's ball as well. More than that, when you look at the Heckler series ball, you'll notice that it has a moderate RG just to the high side of medium, 250. The competitor ball, 251. The total differential starts at a very specific number, 051. The competitor ball, a very specific number, 051. And while they have 15 points of intermediate differential, we elected to go with 10 points of intermediate differential. That gets you just enough asymmetry to be considered asymmetric, and we didn't want too much asymmetry after drilling for no-thumb bowlers because of how high you can make the intermediate differential when you drill into that zone number 3. So we chose a slightly lower intermediate differential. They chose a slightly different intermediate differential. But when you look at the cut ball cross sections that I'm going to put on the screen now, even though the core shapes themselves do not bear out as very similar, the underlying principles of the moment arm locations and your ability to hit them with certain distances from the dot to the center of grip become very, very apparent. And if you take it a step further, I can number our patent pending system by zone. Zone 1, where you hit the top of the core and weaken the layout. Zone 2, where you miss most of the core with the finger holes being drilled into it. You have more neutral layouts akin to the undrilled ball. And zone number 3 of strong layouts. Now let's take a look at the cut ball cross section for the competitor ball. And you can play the same game, labeling them in the same exact manner, and not only are there similarities to the zone areas, but the distances correlate almost exactly. Whether or not there's been any tracing paper involved in the innovation department over there is to be said. I'm not saying that they did or didn't copy our system, but I am saying that the system is patent pending and that there is a suspicious level of similarity between them. Now, we have been doing post-drilled numbers on these cores, both the Radical cores and the DV8 cores. That is because there is a very large performance difference in the core numbers based on where you put the gripping holes, whether it be the fingers and the thumb for the radical core system or just the fingers for the DV8 system. So it is very important that the end user, the pro shop operator, and of course the customer knows exactly what type of performance numbers they're getting out of this core system after drilling. So because of that, Radical publishes their drill sheets with recommended layouts and post-drilled numbers for all of their layouts in every ball box and on the website on their resources page. And DV8 also has a no-thumb resources page, dv8bowling.com/no-thumb resources. You can also scan the QR code on the ball box to get to the no-thumb resources page. If you scroll down a little bit, you'll also notice there are post-drill numbers for the DV8 stuff as well. This is just for no-thumb bowlers and just the no-thumb core designs, but you'll notice the wide range of post-drill numbers. This PDF allows you to see what kind of numbers you're getting. It's hard to say to what degree or to what magnitude you are getting different values when you drill your finger holes or fingers and thumb in different locations in the competitor's ball, because they haven't published those numbers for us. But what I can say is on their info sheet, they do highlight a section in the no thumb layout category that highlights the 3.5 to 5.5 inch dot to center of grip distance, or pin to center of grip distance in their case, as the distance that you use to achieve hitting the procession wing with their layout system. Their core does have a flip block, and yes, you can say that the procession wing is nowhere near the moment arms that the radical cores have, but I made a point earlier of saying that the radical cores, despite being near the mass bias, are certainly in the northern hemisphere of the ball above the equator. And more than that, the DV8 cores very much have their band system with their core sides in the range of 3.5 to 5.5 inches. So no matter how you slice it, the material, whether or not it's copied, certainly isn't new to the industry. We've been designing cores like this since the Troublemaker series in 2022, and we filed for a patent for this exact idea in 2023. Radical's been designing cores like this since its inception in 2013 with Mo and Steve working together. Steve continues that legacy with Mo Pannell passing on. However, they were working on this type of concept as early as 2010 and 2011 with the Mo Rich cores prior to being adopted by the Radical family. So keep in mind that just because something is new to one company doesn't mean it's technologically groundbreaking, new, or innovative. We strive to be as innovative and independent as we can be here at the Brands of Brunswick, and especially with the DV8 brand. We are truly designing cores that we feel like are beneficial to no-thumb bowlers, that give you the widest range of options after drilling for no-thumb players, especially now that balance holes or weight holes and thumb holes have been eliminated from use for no-thumb bowlers, and only your gripping holes are allowed to be drilled into the ball. It is because of this that we set out to design cores for no-thumb bowlers in 2022, and they will continue to be a strong staple in the DV8 lineup for years to come. I've got some great new innovations coming down the line in terms of no-thumb bowlers and their target numbers. The range of motions is going to be expanded for DV8 in 2026, and I can't wait to show you what we've got coming up. In the meantime, check out dv8bowling.com, check out the No-Thumb resources page, and make sure you check out one of our 3 core designs that are designed specifically for no-thumb bowlers with just 2 fingers drilled into the core. You're going to get an expansive range of motion, and because of our post-drilled chart, you're going to know exactly what you're getting before you put the holes into it. My videos usually aren't this intense. Typically, this is a review channel where I'm talking about the new core designs and the new cover stock pairings for the new balls in the Brands of Brunswick. So if you're interested in any of the January releases, make sure you check my YouTube and Facebook page at Bowling Buckosh. While you're there, give me a like and subscribe if you're interested in ball reviews that are TED Talk videos like this one. I get into all the details of the core designs, and if a core already exists and we're doing a cover refresh over top of it, then I'll do a short 1-minute review on my Shorts tab on YouTube. So check my Shorts tab, check my long form videos, like and subscribe, and I will see you in the next video.